Dear students, in the previous lecture I discussed Z parameters and Y parameters. In this lecture, we will discuss H parameters and G parameters. So let's start with H parameters. The matrix equation of H parameters is V1 I2 equal to H11, H12, H21 and H22 into I1 V2. That means we see that the current of input port and voltage of output port is written in the term of voltage of input port and current of output port. That's why its name is hybrid parameters. So when we simplify the equations, we get V1 equal to H11 into I1 plus H12 into V2. Similarly, we get I2 equal to H21 into I1 plus H22 into V2. Now, the steps for calculations of hybrid parameters, again we will have two steps. From the right hand side of the equations, we can see that there are two parameters I1 and V2. So we'll have to make V2 equal to 0 and then we'll make I1 equal to 0 for the calculation of hybrid parameters. So first step, we make V2 equal to 0. So when we put V2 equal to 0 in the equation 1, we get H11 equal to V1 divided by I1. The condition is V2 equal to 0. Again, by putting V2 equal to 0 in equation 2, we get I2 equal to H21 into I1. From here, H21 is equal to I2 divided by I1. The condition is V2 equal to 0. Next, step 2. Step 2 will make I1 equal to 0. When the input current I1 is made 0, so from equation 1 we get V1 equal to 0 plus H12 into V2. From here H12 is equal to V1 divided by V2. The condition is I1 equal to 0. Next, from equation 2, I2 is equal to H22 into V2. From here H22 is equal to I2 divided by V2. Condition is I1 equal to 0. So we got all the four hybrid parameters, that is H11 equal to V1 divided by I1. That means the input voltage divided by input current, and hence H11 is also called input impedance. Next, H22, that is equal to I2 divided by I1. That means current of output port divided by current of input port. Hence it is also called forward current gain. Next is H12. H12 is equal to V1 divided by V2. That means input voltage divided by output voltage, and hence it is called reverse voltage gain. Next is H22. It is equal to I2 divided by V2. That means output current divided by output voltage. So it is also called output admittance. So we see that H11 and H22 have units. H11 has the unit of ohm and H22 has the unit of per ohm, while H21 and H12 are unitless. So this is hybrid parameters. When you have studied transistors, so in transistors you have seen that in the transistor we develop hybrid model of the transistor. This is the reason of developing hybrid model of transistor, because the hybrid parameter is the only parameter that is giving you input impedance, output admittance, forward current gain and reverse voltage gain. So this parameter is really very important for all the electronic circuits. Next, we have a numerical problem for finding hybrid parameters. We see that in the question we have two resistors of value 4 ohm in series, and in the shunt we have two resistors, one has value 2 ohm, another has value 6 ohm. We have to find hybrid parameters. The first step will be V2 equal to 0. That means secondary terminal will be short circuited. When secondary terminal will be short circuited, we can see that the shunt branch having resistance 6 ohm will have no role, because with the 6 ohm resistor now we'll have a short circuit branch in parallel with this, and hence there will not be any current flowing through this 6 ohm resistor. So now for this calculation, that means the calculation of step 1, we can remove the 6 ohm resistor from the circuit. And what will you do? We'll connect battery of V1 volt in the primary side. In the input side, we see that current input current is I1. Now this input current I1 is being divided into two branches. One is 4 ohm, one is 2 ohm. Again, by applying current divider rule, we see that current flowing through the 2 ohm resistor is 2I1 by 3, and current flowing through the 4 ohm branch is I1 by 3. Now by applying Kirchhoff's voltage law in loop 1, we can write minus V1 plus 4I1 plus 2 into 2I1 by 3 is equal to 0. From here V1 is equal to 16I1 by 3. That means we can write H11 equal to V1 divided by I1, and it is equal to 16 by 3 ohm. Next, we see at the secondary side across the 4 ohm resistor, the current from left to right is I1 by 3, and current flowing from right to left is I2. That means I1 by 3 is equal to minus I2. From here we can write H21 equal to I2 divided by I1, and it is equal to minus 1 by 3. Next, step 2. Step 2 is I1 equal to 0. That means input current will be 0. It means input terminal will be open circuited. So when we open circuit the input terminal, we see that the voltage across the input terminal V1, now the same voltage will appear across the 2 ohm resistor at the input side, because there is no any current flowing through this 4 ohm resistor at the input side. Next, we will connect a battery of voltage V2 volt across the secondary terminal, and the current entering through the secondary terminal is I2. Now this current I2 is being divided into two branches. One branch having resistance 6 ohm, and another branch is also the combination of 4 ohm and 2 ohm resistor in series. That means 6 ohm resistor. So this current is equally divided into these two branches, into these two paths. Hence the current flowing through the 6 ohm resistor will be I2 by 2, and similarly the current flowing through the combination of 4 ohm and 2 ohm resistor will also be I2 by 2. Now by applying Ohm's law across the 6 ohm resistor, we see the voltage across the 6 ohm resistor is V2. So V2 will be equal to 6 into I2 by 2. That means the current flowing through the 6 ohm resistor, that is I2 by 2. From here we get V2 equal to I2. So we can write H22 equal to I2 divided by V2, and it will be equal to 1 by 3 per ohm. Next is V1 equal to 2 into I2 divided by 2. That means voltage across 2 ohm resistor is V1, and we can write this voltage equal to 2 into current flowing through the 2 ohm resistor, and the current flowing through 2 ohm resistor is I2 by 2. So we can write V1 equal to 2 into I2 by 2, and it is equal to I2. So V1 is equal to I2. Next, by dividing equation 1 and 2, that means equation A and B, we get V2 by V1. V2 by V1 is equal to 3I2 divided by I2. That means V2 by V1 equal to 3. From here we get V1 by V2 equal to 1 by 3. That is the value of H12. So we got all the 4 hybrid parameters, H parameters. Now we are writing in the form of matrix: 16 by 3 ohm, 1 by 3, minus 1 by 3, and 1 by 3 per ohm. Next is G parameters, that is inverse of H parameters. It is also called inverse hybrid parameters. So how will you write? We have to simply inverse the hybrid parameters. That means in the case of hybrid parameters, we written V1 I2 equal to H into I1 V2. Here we write I1 V2 equal to G11, G12, G21, G22 into V1 I2. So by simplifying the matrix, we get the equations I1 equal to G11 into V1 plus G12 into I2 and V2 equal to G21 into V1 plus G22 into I2. Now we see that we have two parameters in the RHS side, that is V1 and I2. So we'll have two steps. In the first step we'll make I2 equal to 0. In the second step we'll make V1 equal to 0. So when I2 is equal to 0, we'll put the value of I2 equal to 0 in equation 1 as well as in equation 2. So from equation 1 we get G11 equal to I1 by V1 per ohm, and from equation 2 we get G21 equal to V2 divided by V1. The condition is I2 equal to 0. Next step 2 will make V1 equal to 0. When V1 will be 0, from here we will write G12 equal to I1 by I2. The condition is V1 equal to 0, and G22 will be equal to V2 divided by I2. The condition is V1 equal to 0. Now we have a numerical problem. We have a network having 4 ohm and 2 ohm resistors in series and 4 ohm and 6 ohm resistors in parallel. We have to find G parameters. Again, the first step is I2 will be equal to 0. That means secondary terminal will be open circuited, and a battery of V1 magnitude will be connected across the input port. When the battery V1 is connected, it delivers a current of I1 in the 4 ohm resistor. Now this I1 current is being divided into two paths, one resistor having 4 ohm value and another branch is the combination of 2 ohm and 6 ohm resistor. So by applying current divider rule, we see that current flowing through this 4 ohm resistor is 2I1 by 3, and current flowing through the combination of 2 ohm and 6 ohm resistor is I1 by 3. So now by applying Kirchhoff's voltage law in equation 1, that means in the loop 1 we will apply Kirchhoff's voltage law, we get minus V1 plus 4I1 plus 4 into 2I1 by 3 equal to 0. From here V1 is equal to 20I1 by 3. That means from here we get G11 equal to I1 by V1, and it will be equal to 3 divided by 20 per ohm. Next V2, we see the voltage across 6 ohm resistor is V2. So we can write Ohm's law across the 6 ohm resistor. The current flowing through the 6 ohm resistor at the secondary side is I1 by 3. Hence we will write V2 equal to 6 into I1 by 3. So it will be equal to 2I1. The equation is B. Now by dividing equation A and B, we get V1 by V2 equal to 10 by 3. From here we get G21 equal to V2 divided by V1, and it will be equal to 3 by 10. Now step 2. The step 2 is we will make V1 equal to 0. That means primary terminal, input terminal will be short circuited, and we will connect a battery of voltage V2 across the secondary terminal, and the current entering through the battery is I2. Now we have to find rest two G parameters. So we see in the loop 1 we will apply Kirchhoff's voltage law. We get 4I1 plus 4 into I1 plus I2 equal to 0. From here we get G12, that is equal to I1 divided by I2, and it is equal to minus 1 by 2. Next we have to calculate G22. So for the calculation of G22 is simply V2 divided by I2, that means output impedance. So to calculate the output impedance, what we do, simply we will find the equivalent impedance looking from the output terminal. That means we see that 4 ohm and 4 ohm resistors are in parallel, so its resultant will be 2 ohm. Now this 2 ohm will be in series with the 2 ohm resistor, so it will be 4. Now we will find the equivalent resistance of 4 and 6, that is we get the value V2 by I2 equal to 12 by 5 ohm, that is the value of G22. So from here we get all the parameters. G is equal to 3 by 20 per ohm, minus 1 by 2, 3 by 10 and 12 by 5 ohm. So this is all about H parameters and G parameter.